electrostatics, right? Okay.
Okay.
So electrostatic, please be loud when you speak. Connect your earphone also.
Yeah, it's connected.
Okay. So see, electrostatics actually comprises of two chapters in physics. That is, if you look at NCERT broadly, first is the electric charges and fields, right?
Yeah.
And the
Yeah.
second one is electric potential and capacitance.
Yes.
Okay. Now, this, as per the NCERT, this is of 8 marks. All right.
Both the chapters.
Pardon?
Both the chapters 8 marks.
She's saying both the chapters 8 marks.
No, yeah, both the chapters are of 8 marks. Yes.
Okay.
So, yeah, we are starting now the electric charges and fields. So, let me make you understand the meaning of this word, that is the electrostatics. Okay. Electrostatics. What is the meaning of this word? See, if you divide this word into two parts, electro means what? Charge. And static means what? Something at rest.
Yeah.
Something at rest. So the branch of physics which deals with the charges which are at rest is known as electrostatics. Now, how to understand this thing? Let us understand by an example. See, suppose this is a bus, right? Okay, and this bus, many people are sitting, and this bus is moving with a constant velocity. Okay, then if these two people will look at each other, then they will be at rest with respect to each other. Bus is moving, the system is moving, but the people which are inside the bus will be at rest with respect to each other. Similarly, in the electrostatics, what is happening, that instead of bus, suppose any system is there, and instead of passengers there are charges. Okay, this is charge Q1, this is charge Q2, this is charge Q3. Okay, even if the system is moving, suppose with the velocity v, but charges will be at rest with respect to each other. So what I mean to say, the branch of physics which deals with the charges which are at absolute rest is known as electrostatics. It's very simple. You can write the definition. Please write.
Yeah.
The branch of physics. Are you writing?
Yes, I'm writing.
Okay. The branch of physics which deals with the charges which are at absolute rest, which are at absolute rest, is known as electrostatics. Okay.
Okay. Yeah.
So if you want to copy this on the board, you can just copy if you want to. Rest all in the regular classes, we will be like, there will be some recording session in which you can save these things also. It is very easy to save. So right now I'm just because it's a demo session, I'm just clearing it.
Okay. Okay.
Okay. So let's start the very first topic of this chapter, that is the electric charges.
Okay.
Okay, electric charge. So the question arises, what is an electric charge? Right? In your junior classes, you might have studied charges are of two types. One is positive and other is negative.
Yeah.
All right. But according to the physics, as said by the very famous physicist Michael Faraday, what Michael Faraday has told, that there is no definition of electric charge. It has no definition. Right? So what is basically an electric charge? It is no definition. See, it is a property of the matter. It is a property of matter. Charge is what? A property of matter by which we can define electric force. By which we can define electric force. right? So if you want to define electric force, then you need a property that is known as electric charge. Have you studied mass in your class 11th? I think yes.
Yes. Yes.
So
Yes.
the same thing, that the mass is also not having definition. What is a mass? Mass is a property of matter. That is simply the definition of the mass, but it is not the real definition. Similarly, charge is also not having definition. It is just a property of matter by which you can define the electric force. So now comes what is the unit of charge in physics? So what is the unit of charge in physics? In SI system, the unit of charge is what? It is coulomb. COLOUMB, coulomb. The symbol is what? C. Okay. And what is the smallest unit of charge? It's a very important question, can be asked in 1 mark. What is the smallest unit of charge? That is Faraday. Faraday is the smallest unit of charge. Okay, in the FPS system. Right? In CGS, that is centimeter gram second. What is the unit of charge? State coulombs. STAT, state coulomb. Okay, you will not be using state coulombs. You will not be using Faraday. We will be using what? Coulombs itself. All right.
Okay. Okay. Okay.
You can note it down if you want to.
Yeah. Done.
Okay.
Yes.
I'm just off my video.
Okay.
Now let's do what the very important part of the chapter. That is what? That is about the properties of the electric charges. This can be asked in exams. There are many properties of electric charges, right? So firstly, how many types of electric charge we are going to study? One is positive, that is
Negative.
proton. Okay, other is negative, that is electron. All right. There are other types of charges also, my dear, but that is something, which we are not going to study, right? वो हम study नहीं करेंगे. We are not going to study those charges like positron, neutrino, etc., which we are going to study in the atomic physics and such kind of topics in the later part of physics. Right now, we will study only proton and electron. So the first property of electric charge says what? That charge cannot be created. That is a property of conservation of charge. Charge cannot be created, nor it can be destroyed. Right? Nor it can be destroyed. Right? So this property is known as conservation of charge. Charge follows the principle of conservation. So this is a property of conservation of charge. It's very important. Okay. Second property of charge says what? What is the second property of charge? It says what? That is the additive property of the charge. Additive property. Additive property. What does it say? That net charge on any system, remains the constant. This is simply the corollary of the conservation of charge only, but it is defined as the other property. I will explain you how. Net charge on any system remains constant. That means what? Suppose this is a system. There are many charges, plus Q1, minus Q2, plus Q3. These are the charges. So what is the net charge on any system? Additive property says what? क्या बोलते हैं? Additive property says what? That we have to add charges algebraically. If it is constant, then you just add them algebraically. What is the meaning of algebraic sum? You have to include sign also. That is plus Q1, then minus Q2, then plus Q3. This is the answer. What is the example? This is a system. The charges are what? Minus 3 coulomb, plus 8 coulomb, minus 10 coulombs. So what is the total charge on the system? Minus 3 plus minus 10. So what is the answer? Minus 13 plus 8. So what is the answer? Minus 5 coulomb. This is the answer. Okay?
Okay.
Right? So this is the answer. So you can note down this also. Please note it down.
Yeah.
Other than this, I will give you some regular notes also. This is just a classwork note. That's why I'm asking you to note it down. Otherwise, in the next class, what we can have the recorded sessions and you can look those sessions again, right?
Yeah. Yeah. Yeah.
So for this class, just note it down.
Yeah. I finished.
Okay.
Yeah. Done.
Done? Okay, fine. So now I'm teaching you the most important part of the property of the charges. That is what? That is the third property. That is the law of quantization of charge. Law of quantization of the charge. Law of quantization of charges. This is the most important property. So this word quantization is the word. This word is coming from the word known as quanta. Quanta. This means what? Packet. Okay. So how will I explain this law to you? See, suppose you have a bag. It is a bag in which there are large number of cricket balls. Many number of cricket balls are there. Okay.
Okay.
These are the cricket balls. All cricket balls are same. They have the same radius. They are the same shape. Am I right?
Yeah. Yes.
Now my question to you is, how many balls you want to pick from this bag? Can you tell me any number?
3.
Okay, 3. I give you one more chance. Any other number?
6.
6. Okay. If I ask any other student, he will say 8. Somebody will say 1000. Somebody will say 7. Somebody will say 12, etc. Right? Can you pick 3.2 balls from this? Is it possible? Yes?
No. No.
No. Yes. Okay. Of course. Can you pick 6.3 balls from it? Is it possible?
No.
Yes. Yeah. No. You know, because why? Because it is very clear, very much clear that you cannot divide this ball. You cannot cut the ball and you cannot pick it up. Similarly, law of quantization of charge says what? Instead of these balls, okay, suppose in a system there are large number of charges. Let's say electron, 1 electron, then 2 electron, then these are the electrons, right? Now I want to pick the electrons from this bag. So you cannot cut the charge and you can pick the up. You cannot cut the charge. It's not possible. Okay, so you had to pick the complete charge in the form of a packet. That means what? What does the law of quantization of charge says? What is the law? It says what? That charge exists in the form of integral values. Integral values. You know what are integers?
Yes.
Integers are what? Plus minus 0, plus minus 1. 0 is not, 0 is considered to be integer, but it is like plus minus 2, plus minus 3, and so on. We don't consider 0 here, okay? Because 0 means no charge. That's why plus minus 1, plus minus 2, and so on, right? So charge can exist in the form of the integral values. It's very important, right?
Okay.
Understood the law?
Yes. Yes.
Now, if you want to write, just write this line only. Charge exists in the form of integral values, and then I will dictate you the formula.
Yeah. I wrote it. Done, sir.
Done? Okay. Now, let me tell you the formula. See, my dear, that suppose in a bag, in a system, there are n number of charges. Many number of electrons are there. I don't know how many number of electrons are there. So what I say that n number of charges are available, right? Okay.
Yes.
And value of charge is what? Value of charge is what? That is E. Okay. What is the value of E? That is 1.6 into 10 raised to power minus 19 coulomb. This is the value of E. So what is the total charge? what is the formula of law of quantization of charge? Total charge, what is the formula? N times of E, okay, where N is an integer. N is an integer. This is a very, very important formula. We are going to use this formula in many questions in physics, many chapters. What is the value of N? N is plus minus 1, plus minus 2, plus minus 3, and so on. All right? Yes?
Yes, E is
Okay.
the
So this is the
charge,
formula
right?
which you get from the law of quantization of charge. That is Q is equals to N. You can simply write this as what? You can write small q or you can write smaller, bigger q. That's make the same sense. That is Ne. Q is N times of E. This is the formula. Very
Okay.
important. It will be used in many chapters. Okay?
Okay.
Right? You want to write this? Please write this.
Done, sir.
Done? So now the last thing about the charge that is also very important, that we have already studied the law of quantization of charge. It says that the charge cannot exist in the form of the fractional values. It is an integer, right? Okay, but there is one species which is known to the science that is known as quark. Okay, this quark is what? This is a special kind of species which violates the law of quantization. What does it says? That law of quantization says that charge can exist either in this form 1e, 2e, 3e, 4e, and so on. Quark is what? It is a fractional value of charge. That is what? It is 2 by 3 of electron plus minus. Plus minus 5 by 7 of the electron. These are the fractional values. Am I right?
Yeah. Yeah.
These are not the integral values. So this type of species, if you find, where you find this number like 2 by 3 is what? 0.666, something like that. Okay. 5 by 7 is also non-terminating but repeating decimals. Okay. If 5 by 7 is what? Point, if you apply point what? 7 sevens are 49, then 1, then how much? Then 3, then 7, 4, then again 2, then 7, 2, and so on. It is also non-terminating but repeating decimal. These kind of species are known as quark. Okay, these are the special kind of species. The detailed theory of the quark is not there in our syllabus. Okay, just this much knowledge. Now, one question was there, that is this plus minus 1 by 2 of E is a quark or not? So the answer is no, it is not a quark. Why it is not a quark? Because plus minus 1 by 2 is what? That is 0.5. Okay, this is not a non-terminating decimal. Okay, the answer is there, 0.5. Now I ask you a question: is plus minus 1 by 5 E is a quark or not? Tell me.
No.
You are right, it's not a quark. Why? Because plus minus 1 by 5 is what? It is 0.2, and 0.2 is again the terminating decimal, so it is not a quark. Very good. Okay, so this is all about the properties of the charges. Okay, this topic is now ended. Now in the regular class we are going to start with the methods of charging, right?
Okay.